Then what will be those? There might be few who have finished it. What would be the steps now? We are writing a differential equation. This is IT. So let this we can call as I1t, and this will be, this will not be calling I2t, this will be IT minus I1t. This is IT minus I1t. And then we shall try to, then one more thing which may be required, that is V1t, and maybe you are required to have presumed something as V2t, right? And based on this, we have to generate a differential equation. In the final differential equation, nothing of this should come. I1t, V1t, V2t should not come. What we must get a differential equation between VT and IT. We must get the differential equation between VT and IT. So we may again we will have same exercise. I will try to put the different relationship equations in assorted form, and we are supposed to club up. So what we can have, first equation which we can get is V in t minus V1t is equal to IT, right? Because R is 1 is equal to I. That first equation. Is all right? First equation. Then ultimately we want between VT and IT. VT and IT. So V1t we must get rid of. V1t we must get rid of. Is it all right? So V1t we will also get another equation. What is V2t? V2t is very simple in this sense, is equal to 2 into bracket IT minus I1. 2 into IT minus I1. Right? 2 into bracket IT minus I1. Now V1t minus V2t d by dt is equal to what? Into 2 is equal to IT minus I1t. Agreed upon? Is agreeable? It is voltage across capacitor V1t minus V2t. C dV by dt is equal to IT. ICT. So C dV by dt is equal to this current. Then what else you can have? dV1t upon dt is equal to I1. So for each component there are 4 components, 1, 2, 3 and 4. each component provides us a peculiar relationship between voltage and current in either direct form or in differential form. So we have written 4 equations, each for one component, and using these 4 equations we must get an ultimate equation between V in T and I in either direct or differential form. So how can you, so the first equation all right, only thing is that I must get rid of V1T. I must get rid of V1T. So how can I get that rid of? So what now? 4, see, no more new things is going to add because 4 components, 4 equations we have finished up. So using these 4 equations only, I must have appropriate substitution in order to get something between V in T and IT. So now you differentiate first equation. You differentiate first equation. What we get? When you differentiate first equation, you get dV, I write here, dV T upon dt minus dV1T upon dt is equal to dIT upon dt. Now this dV1T upon dt is nothing but I1T. This is I1T. But this is of that way no use because I got rid of V1T, but I got I1T which also I do not want. So this is something which I can replace now. dV1T upon dt you can replace now. I hope that you are either appropriately noting down or you are supposed to view the things at a later stage. You either write down now or you are supposed to view at later stage because we are replacing in place computation. So here we are putting I1. We are putting I1. Now I should get rid of I1T. I should get rid of I1T also. Then how can I get rid of I1T now? I1T I can put it in terms of, now I1T I can put in terms of minus 2 I1T. This goes on the other side. V2T minus 2IT upon 2. So I can write using this equation I1T is equal to V2T minus 2IT upon 2. But again V2T comes. Again there V2T comes. It is okay, sorry. 2IT minus V2T. It is 2IT minus V2T. 2IT minus V2T. Now here I find some ray of hope because if I differentiate this equation now, if I not differentiate, if I rewrite this equation again, there is a chance of getting rid of V2T there. So differentiate. Now I am looking at these two equations, and from these two equations, can you get rid of V2t? So if we want to get rid of V2t, this I will write separately here, that dV1t upon dt is equal to IT. And we will be having open question test on Tuesday. On Tuesday, we will be having the test based on only this: constructing a differential equation for given circuits. Constructing a differential equation for given circuits. Circuits parameters will change. Circuit arrangement and parameters will change, but the problem is same. Now, if we rewrite it, it is 2 dV1t upon dt minus 2 dV2t upon dt is equal to IT minus I1t. IT minus I1. Then I now can see I need to differentiate this. So dI1t upon dt is equal to, that 2 will go here, so it will be dIt upon dt minus what? Half dV2t upon dt. So now I think we get something very easily here. What we want to replace this I1t. So if I look at this equation and this equation, and in this equation if I replace this, so dV1t by dt is IT. So it is 2IT. Is 2IT minus 2 this dV2t by dt is equal to this. What? What is I1? So what happens now? That this comes on the other side. So it goes from here. So it is 3I1t. 3I1t. So it goes on the other side. Plus 2dV2t upon. And now what you can do? dV2t by dt you can replace doing this. But there what we have again? You I1t there. We have I1t there. So anybody who has found the solution? So there we again get so 3I1t is equal to this. So we are stuck up somewhere. We are stuck up now. So in the calculations we are stuck up. What is the way out? What is the way out? Anybody has got the answer? What is the final answer you got? tried one way but found that we are stuck up. This actually constructing the differential equation, I think that in your very early days you might have, I do not know whether you might have solved such puzzles where there is the different pathways are there which are blocked at one point, and there is maybe one mouse who starts from one place and there is one destination. So what you do is you start in this one way, you feel that you are going close to destination, but you find that at very close to destination you are stuck up. So you have come back to the original point and trace from some new path. So it is just path tracing puzzle, because if you try to wander there only, then you get stuck up. So it is always better to have a different path. This is these are the problems for which solution exists, solution can be found. There are no new revelations in the solution, but only thing is that the finding out an appropriate equation is something not straightforward, or is something which takes time. So we must have patience to withstand ourselves till we get the solution. So we forget now when we want to have a solution, we forget everything till now and proceed again. The concepts are same, that all four components will exhibit some relationship between V and I. So that is the only thing available, and that is enough. Means that knowing up of that relationship is necessary as well as sufficient for us to come to the final equation. So we may again redo from start. Just only we may change some approach. So this V1 is must. Taking V1 is must. Whether this is required or not, we can come at a suitable point. So first is V in T minus V1T is equal to I. In that there is no change. In that there is no change. In that there is no change. Then its differentiated form is dVt upon dt minus quite obvious. Now we want to get some relationship to get rid of I1T. To get rid of I1T, we need some relationship. For that, obviously, one relationship what we have is this I minus I1T, IT minus I1T. So what we may get now, V1T we have, this would be, so one relationship what we can get, d by dt, 2d by dt of V1T minus 2 into bracket IT minus I1T is this correct? what it must be? V1t minus this, its differential must be it minus I. This is what we have tried. We have tried to write a bigger equation. Current through capacitor is equal to C into dV by dt, which is the voltage across it. So current through capacitor is it minus I1t. Voltage across it is V1t minus this voltage. This voltage is what? 2 into this. And its differential. So this is a big equation we have got. In this big equation, we may get the terms. What terms you get? You write down. And there may be a need to differentiate once more. There may be a need to differentiate once more. So from this what we get? 2 dV1t upon dt minus 4 dit upon dt plus 4 di1t upon dt is equal to it minus I1. That's what we have got. In place of I1t, what we can put?
dVnt upon dt minus dit upon
I1t. This we are taking from this dV1t by dt. Answer is there. What is the final? It's how much long? Whether it is first differential or second differential? Second. So we need to go differentiate once more. We need to differentiate once more. So if we differentiate this equation again, what we get? d2 vt upon dt square minus d I1t upon dt is equal to d2 it upon dt square. And there now what we can find is this 2 d1t upon 2 dv1t upon dt is I1t only. This I1t what we have. So we may get a relationship here between I1t something di1t upon dt, but what we want exact relationship between these two.
We can find the value of I1t from above this and from below this we can find out the di1t.
From I1t we will find from I1t, right, and that we can put it here directly, right? Yes, so what he has suggested is find I1t from this. So I1t is available, differentiate it. So di1t by dt is available and put that here directly. So this equation here, first this is 2I1t. So this comes on the other side. So it is 3I1t minus 4 dit by dt plus 4 di1t by dt is equal to it. Now, so best idea is this. So I1t is equal to d vnt upon dt minus d it upon dt, and its differential di1t upon dt is equal to d2 vnt upon dt square minus d2 it upon dt square. And then simply substitute this and substitute this in this equation. So when you substitute I1t goes, when you substitute di1t goes, and what remains is dit upon dt, it, dvt upon dt, dit upon dt, d2 vt upon dt square, d2 it upon dt square. So it is everything what we want. Means everything what we don't want, we have got rid of it. So it may be bigger equation. Okay. Recording off.